The idea came kind of out of the blue. In the late 90s, I was visiting a friend in France, and this friend by name Alain Belly. We were having a beer somewhere in Lyon, and as usual we were discussing the problems on the energetics of running. And we were considering that whereas running at constant speed on flat terrain or uphill or downhill as a function of the slope is very well known since quite few years. On the contrary, when it comes to accelerated running, like in sprint running, or decelerated running, our knowledge was essentially negligible. Nothing was really known. And this is partly due to the fact that whereas for long distance running at constant speed, it is possible to reach a steady state, so it is possible to measure very easily the energy expenditure of the runner. But when the time is short, like in a 100-meter to 400-meter sprint, the time is so short that it was in those days, and even nowadays it is impossible to make any precise measurement of the energy expenditure. But then all of a sudden I consider the fact that when somebody is running on flat terrain, accelerating, he leans forward. The more so, the faster the acceleration. So if he accelerates very much, he will be down like so. If he accelerates less, he will be more vertical. But this is entirely similar to lifting the terrain up in respect to the horizontal in such a way to maintain the body, the angle between the main axis of the body and the terrain equal in the two conditions until the body axis is brought up vertical. And this condition is exactly similar to somebody running uphill. This was the basic idea, and we started thinking how to transform the acceleration, that must of course be measured, in the equivalent slope, the slope that would bring the subject's body up to a vertical position. This took us some time, but in 2005 we published a theoretical and practical work on the Journal of Experimental Biology, and Alain Belly was among the authors, and some of his younger colleagues like Jean-Benoît Morin and some colleagues of mine here in Udine, Guglielmo Antonuto and others. We measured the acceleration on 12 medium-level French sprinters, and from there on we made all the calculations. And 5 years later, in 2010, two Italian colleagues, Christian Ochsner and Stefano Poser, applied this approach to soccer, because of course in soccer this is very important, because in soccer there is not such a thing like running at constant speed, or very rarely. Subjects are always accelerating or decelerating. So it's always like they were running uphill or running downhill. And this, once we have made this equivalence between acceleration and slope, it is very easy to transform the acceleration into the corresponding energy cost, because we know very well the energy cost of running at constant speed uphill or downhill. Very long story.